Within this type of VPN, there are two distinct network types. An intranet site-to-site VPN is able to link several sites from the same organization. On the other hand, an extranet site-to-site VPN is able to link several sites from different organizations. So that option would be better used for companies that frequently collaborate with third parties. And then the last type of VPN is a VPN application. It's best suited for mobile users who want all the same benefits of using a VPN but on a mobile device. It's a great option for those that regularly have an unstable internet connection or connect to public networks, as it continues to protect your information even while the internet is a little spotty. VPNs basically work by using tunneling encryption protocols that act as rules for sending data. Data sent through this tunnel gets scrambled into code and left unreadable by anyone who doesn't have permission to read it. Once the data reaches the server uses its own private key to decrypt the data and make it readable. And then it will send the readable data along with a hidden IP address to the site that you're trying to connect to. So the Advanced Encryption Standard, or AES, gives detailed instructions on packaging the data as well as deciding which checks it needs to perform upon reaching its destination. These protocols will have a direct impact on the process speed and security, so knowing what protocols your VPN uses can influence your decision in selecting one. Transmission Control Protocol, or TCP, is one of the basic communication standards that allows application programs and computing devices to exchange messages over a network. It works by establishing a connection between a source and a destination. It will ensure that this connection stays alive until the communications begin. Then it will break down the large amounts of data into smaller packets to send while ensuring the integrity of the data. Because of its reliability, it's one of the most commonly used protocols and high-level protocols that need to transmit data. User Datagram Protocol, or UDP, is an alternative to TCP. It'll establish a low-latency connection between applications to decrease the amount of time it takes to transmit data. So, unlike TCP, it doesn't signal a destination before it delivers the data, which makes it a little less reliable, but also cheaper. Because of this, it's a really good option for time-sensitive situations like streaming media, for example. SSLs and TLS are the same protocol. Transport Layer Security, or TLS, is an updated, more secure version of SSL, but for the sake of commonality, the term SSL, or Secure Sockets Layer, is also still used. So these are a few protocols that are pretty common. OpenVPN is an extremely popular protocol that uses a 256-bit encryption, which is currently the industry standard. It uses both TCP and UDP, SSL/TLS, and because of its open source technology, anyone can view its source code and help address vulnerabilities. This may sound scary, but it's actually a good thing because it ensures full transparency and that your data will never be sold or given to any third parties. It is pretty highly regarded as good for overall use. SSTP stands for Secure Socket Tunneling Protocol. It also meets the industry standard at 256-bit encryption and uses TCP and SSL/TSL. It is built into Windows operating systems and supported by Microsoft, which makes it one of the best options for Windows users. IKE version 2 stands for Internet Key Exchange version 2. It is a protocol that is normally paired with Internet Protocol Security, or IPsec, in order to improve security and speed. It uses UDP to maintain your connection, even under unstable internet connections, making it really reliable for mobile VPN users. L2TP stands for Layer 2 Tunneling Protocol. It's like the previous protocol in that it uses UDP, and it's often paired with IPsec for that added security boost. It is also built into Windows operating systems. However, a lot of providers no longer support its use as better options, became available. PPTP stands for Point-to-Point Tunneling Protocol. It is the direct parent to the previous one, L2TP, and because of the development of LT2P, its creation has become practically useless. Some free VPNs will still use this protocol, but it has a lot of issues and is not in keeping with the industry standard. It only has 128-bit encryption. WireGuard is a newer protocol that's continuing to gain traction among VPNs. It has greater mobile capabilities and more modern technologies. Like OpenVPN, it uses open source technologies that allow anyone to report bugs and hold providers accountable for any data misuse. So now that we've addressed the different protocols used by VPNs, I feel confident that we can make an educated decision about an actual VPN provider. So to reiterate, strong protocols help ensure the safety of your information as long as it's up to the industry standards of 256-bit encryption. So if you get something less than that, it's not going to be as secure. It's important to consider options for rerouting your IP address to protect your location, among other things. So what this will normally do, it'll take your IP address and group it in with other IP addresses that are kind of in your area, so you get a general region for where you are instead of your exact location. So that's an important thing to consider if your VPN is able to do that or not. If a VPN provider has a range of servers located close to you and far away from you, your data has to travel a much shorter distance from server to server than if there was just really far apart. So your information would get to you a lot faster. A zero-log policy can ensure that the VPN provider doesn't store any data that it gets sent while you're connected to it. A kill switch will help by cutting off your internet connection if your VPN connection is disrupted. Again, this also sounds a little bit scary, but it's actually pretty useful in protecting your IP address. Without a kill switch, your device will revert back to your real IP address, leaving it exposed. So it's not a deal breaker, I guess, if your VPN doesn't have it, but it's nice. It's also worth considering a VPN provider's mobile capability if you plan on using mobile devices like phones or tablets on unsecured networks. A VPN provider that authenticates your credentials before connecting can help maintain your security. It's also a nice plus if they offer multi-factor authentication. Customer support is a little less important than some of these other things in my personal opinion, but it's still worth looking into the experience that customers have when trying to receive help for their questions. And as a general rule of thumb, avoiding free VPNs could help ensure your decision is a real and credible company. Free VPNs don't always maintain the right industry standards. So, as with everything else, VPNs cannot guarantee absolute protection. It can't protect against viruses at all, and while it can prevent advertisers from using cookies to target ads towards you, it doesn't prevent the cookies themselves. So after deciding on a VPN, there is always a chance for security flaws, bugs, or other vulnerabilities, which you can combat by keeping your software up to date. Though there are a few challenges with using a VPN, the added privacy and protection goes a really long way in our current digital age. Right. Do we have any questions?
Which provider do you use?
I currently use Proton VPN just because it's, I just kind of like it.
So I know in my work, I use my VPN as a sense of like, hey, I need to connect to my work to do access on my servers. But on a personal level, just more for security. This difference between like personal use and business use, is there anything interesting about that, or?
I will say that some VPNs are a lot better at handling like companies basically. If you're just using a VPN for you, it doesn't need to be as large scale as some VPNs are. So I would say that there is a little bit of a difference there.
Okay, makes sense. Thank you.
So you mentioned that like some of the VPN protocols use different of the underlying protocols like TCP and UDP and stuff.
Yes.
Does that mean that like certain services will work better with certain VPNs than others? Like with certain VPN protocols than others?
In a way. So let me see where I put it. Let me go back to that. There. Yeah, so I guess in the case of if you're the example I gave earlier, if you're streaming media, then it would make more sense to use something a little bit faster, but a little bit less, secure, so that you can get it, so it's not loading while you're trying to watch.
Yeah. So, cause I think you had mentioned with the protocols, the the other one's on the next slide.
Yeah.
It might be 2 slides.
Right
you
there.
go, yeah.
You had mentioned, I think, that OpenVPN has UDP, but SSTP doesn't. So then would something like, would streaming like be worse on SSTP because streaming uses UDP?
Not necessarily, but probably.
Kind of makes sense.
I guess it really just depends on what you're streaming. Like, you might not notice a difference at all, but if you're streaming something that is like a really large chunk of data, then probably go for an OpenVPN.
Makes sense.
Yeah.
And is WireGuard, I know you said that's new, is it proprietary to something? Is that like somebody's thing? It just sounds like something I would buy from somebody. like we've got WireGuard, or
Yeah.
someone else has it.
I am not entirely sure.
Okay.
But when I was doing research on it, that was the one that I found like just a little bit of information, but it kept being brought up. So
Okay.
Yeah.
Okay.
any other questions? Okay, cool.
Thank you.